Okay, if you're going to record and think about weather and make a weather forecast, you've got to understand what's happening initially, and then from that, how it's going to evolve. So, since we've been dealing with weather and we've gone through all the different variables of it and been looking at weather maps and all, I thought, why not see what we can come up with for a Monday to Tuesday timeframe forecast for Ohio? So, this is one of my favorite charts to look at for this. It's mid-level moisture. The reason I like it, it shows kind of wind patterns, circulations. Notice up here coming into Minnesota, see how this is circling here? So there's some kind of counterclockwise flow in this area of this moisture. It's a mid-level low of some type or another. You can see all kind of moisture coming up out of the Gulf of Mexico here and running into, not really moving. And yet some of it gets ripped up into here. Some more moisture is coming in off the Atlantic into this area. And there's some moisture that's left over from some thunderstorms that went through Oklahoma yesterday here. A lot of dry, probably some kind of jet streak in this area here, and another one up in here. So just looking at this, I'm in Ohio. This feature right here, and the fact that there's a line of probably showers and thunderstorms ahead of it, is something I'm going to wonder about. Will that impact my weather? So then I go on and look at the surface a little bit. And wow, there's a nice big warm front here coming north. It looks like ahead of a low. Yep, that mid-level feature was right in here. So they kind of correspond. They picked it out for me. So I'm going to have this warm front moving north, and I'm going to have this system in the upper levels coming in with it. So now the trick is, okay, I know what's going on initially. How is that going to change, evolve? As we've learned, weather is always evolving and changing. It's never static. So what is this going to look like then? Maybe tomorrow evening. Well, maybe I want to look at the upper level jet. Let's see where the divergence might be with this system and see how that might be changing. So here is a 200 millibar wind forecast. So if I were to move this forward in time, this is a model forecast, high resolution model. It runs at about 5 kilometers right now, which means it's looking at fairly small scale. But a couple things initially. I will notice the jet streak right in here coming through. I had another one over here, but that's gone away. I also noticed the contours. They kind of dip just to my west if I'm in Ohio, and they keep dipping. I mean, this is basically coming into Monday afternoon, and notice they keep getting lower. What's that mean? It means the atmosphere is actually cooling with time. Notice how they're curving in here and all now. A little bit of a jet streak. So there's probably some kind of divergence coming across the area along with this. So that's just looking at the upper level. So I'm looking at some divergence. I'm looking at the atmosphere column cooling. Well, if the atmosphere column's cooling, I got a warm front coming up from the south, coming to me. Somewhere aloft is where it's cooling. So what's happening is my atmosphere is becoming more unstable with time because of that cooling. Well, another thing to look at maybe is this model, a little bit, same model, picks out that low very nicely here. Notice this cold front right here coming down, and the warm front probably right in this area moving through. But here comes that cold front and some precipitation, the model says, on Monday evening. So if you live in Ohio, you can probably expect Monday night into early part of Tuesday to have some precipitation and clouds around. But then after that, probably it looks like high pressure moves in. Well, we know high pressure tends to bring clearer skies. So just looking at those two features, I'm saying, okay, I've got a little bit going on. Now I might want to know a little bit about the temperatures. Well, with statistics, and what happens is we look at how models forecast max temperatures or min temperatures, and then run statistics to see what errors, what biases the model might have. And from that, come up with a new forecast. And this is a model-based ensemble of temperatures. This is just a max temperature. So this is Monday's max temperature. Notice there's some pretty warm air out here in the Midwest getting pushed up, and fairly cool air up here. Notice the wind's coming down like this, but here's we got probably a front right in through here. And this is all model based. So what I'm looking at here is some light green up into here, maybe. Well, temperature is moving upwards, probably in the 75, 80 degree range, maybe even some upper low to mid 80s in this area right in here with time. I can move this out. This is just be Monday, so let's move the next day. And we have more heat humidity coming up. Really in the midsection of the country, looks like it's really going to warm up pretty good now. So now I got some ideas on temperatures. I wanted to show you this because I talk about models not knowing what they're doing very well. And there's a lot of questions, uncertainty in models. The way we determine uncertainty in meteorology is we look at an ensemble of models. So in other words, not just one, but in this case, it's 20-some models, all with either slightly different initial conditions, as you're learning in this chapter. It's really hard to find out exactly where a front might be or what the actual temperature is in a given location if there's not an instrument there. And there's not instruments everywhere in every little spot. And we don't have a really perfect model yet that, oh yeah, this thing's going to move. We can solve these equations perfectly. We can't. So between that, what do we come up with is an ensemble. And look at this. It says, oh, here's a low. In 48 hours, it's already, well, could be here, could be here, could be here. You know, if I'm in Hudson Bay, I might be kind of curious to know where exactly. And another one here. And look how uncertain. There's one moving across just to the north there. So there's a lot of uncertainty in meteorology. Some days these line up beautifully. Sometimes, if you go out in the future, they really, kind of look messed up here a little bit. So when they're close together and stay that way for a while, we feel fairly comfortable in the forecast. When they don't, well, we might want to be thinking about how we're going to have to change it or what we're looking for that might be causing problems. Finally, I just wanted to show you a high resolution model. This is already forecast at about 1 kilometer, so it's a pretty tight grid. And you can see here, this is a simulated radar. And you can see down in my area, there's all kind of radar echoes and stuff. And there's more back in West Virginia and down through Kentucky here, where they've had more than enough rain already. So by using this, I can look at high resolution, maybe in the first 12 to 24 hours and get a good idea, at least some idea of where. And oh yes, we even have ensembles of this, which the Storm Prediction Center uses to try to estimate where severe weather may occur. So as you can see, all of this plays into your forecast, trying to figure out exactly what's going on, and then looking at models, looking at observations to see how things are changing. Sometimes it may be as simple as finding one station that you're curious on how it's changing and how that might impact your weather. I've used, for example, when I was forecasting in Sterling, Virginia, and say we have an ice storm occurring or may occur, I want to know how long the temperature is going to stay below freezing. Well, I used to use Wilmington, Delaware, because the winds kind of come from that direction. So if Wilmington, Delaware was staying below freezing, then I knew that Sterling, where I lived in Washington, D.C., may as well. Especially if I could see colder air even coming into that area. Sometimes you did. You could actually see temperatures dropping in Wilmington. You knew that was rushing the cold air over where I was. So the ice that we were getting is going to continue to stay that way. So hope you got a little bit out of this forecast and concept. And if you have any questions, please don't hesitate to ask.